Welcome to physics class. In today's class, we shall be solving 10 standards midterm paper part A physics. Essay 1 paper that you had written on September 28th. Let us have a look on the solutions. Since this is just the discussion about the solutions of the question paper, we will not be explaining it in detail. Whichever question you need the explanation in detail, you will have to let me know in the comment section. So let us start part A, physics. First question. The SI unit of potential difference is. The correct answer is option B, volt. It is the SI unit of potential difference. What about option A? Option A, ampere. It is the SI unit of current. Whereas option B is the correct answer. It is the SI unit of potential difference. Option C, ohm. It is the SI unit of resistance. Option D, coulomb. It is the SI unit of electric charge. Second question. In Fleming's left-hand rule, the forefinger indicates option A, magnetic field, option B, electricity, option C, motion, option D, potential difference. The correct answer is option A, magnetic field. Coming to the third question. Among the following arrangements of resistors, a combination that gives the total resistance of 13.5 ohm. You're supposed to find out in which combination we will be getting the equivalent resistance as 13.5 ohm. Coming to the option A, we can see that all the three resistors are connected in parallel. Since they are connected in parallel, let us check by putting the formula of equivalent resistance when resistors are connected in parallel. This is the formula. So in place of R1, R2, R3, we are supposed to substitute 9. Since the denominator is same, no need of taking LCM. The denominator will be 9. 1 plus 1 plus 1. That will be equal to 3 by 9. Nothing but 1 by 3. Then RP will be 1 by RP is equal to 1 by 3. RP is equal to 3 ohm, the reciprocal. That is 3 ohms. But what are we supposed to get the answer? That is 13.5. Let me check in option B. Option B, R1, R2, R3 is 6 ohm. Each resistor's value is 6 ohm and all the three resistors are connected in series. So the formula is RS is equal to R1 plus R2 plus R3. 6 plus 6 plus 6, that is 18 ohms. So this is also not the correct answer. Let me check with the option C. First let me check the equivalent resistance of the two resistors that are connected in parallel. That is 1 by 9 plus 1 by 9. That is 1 by RP. We will be getting the value as 2 by 9 and RP is 9 by 2. 9 ohm resistor is now connected in series with RP. That is nothing but 9 by 2. Since these two are in series, we shall check their sum, that is nothing but the equivalent resistance, that is 9 plus 9 by 2. The LCM will be 2. 18 plus 9 is equal to 27 by 2. RS is equal to 27 by 2, that is nothing but 13.5 ohms. Hence, the correct answer for the third question is option C for the third question. Coming to the fourth question. Cross section of a conductor is directly proportional to the flow of current. Give reason. So they are telling that area of cross section, we use capital letter to denote area of cross section. They are telling it is directly proportional to the flow of current. Current is denoted by the letter capital I. In physics, you have to keep in mind whenever you're supposed to justify your answer or else give reason for the answer, we always have to go back to the formula and give our justification as a proof. We all know the formula. R is directly proportional to the length of the conductor and inversely proportional to area of cross section. We also know that R from Ohm's law, V is equal to I into R. We know that R will be equal to V by I. So I can substitute V by I in place of R, that is proportional to L by A. Now the fourth question is related to I and A. Since both of them are in the denominator place, we come to know that both are directly proportional. Hence, with this formula, we can tell that if area of cross section increases, the current also increases. This is the justification you have to write. From this formula, it is very clear that current and area of cross section are directly proportional. If area of cross section increases, current also increases. Those who need a detailed explanation about the cross sectional area, directly proportional and inversely proportional, you can check into our channel. There is a very first video we have uploaded, a detailed explanation about cross sectional area, directly proportional and inversely proportional. You can also check the videos that have been uploaded till now. Every concept for which the videos are made, those concepts are covered in the recent Essay 1 question paper. Coming to the fifth question. The magnetic field produced in a circular coil of conductor having 10 turns is 10 times as large as that it is produced by a single turn. Give reason. So they're telling a statement and you're supposed to give reason for that concept. So what is the meaning? A coil with 10 turns. When current is passed to the coil which is having 10 turns, the magnetic field that is going to be produced in the coil will be 10 times each turn, that is the single turn. What is the reason? It is due to the cumulative effect of the magnetic field and the current, and also other reason is the magnetic field strength that is going to be produced is directly proportional to the number of turns. If you want a detailed explanation, let me know in the comment section. I'll make a separate video. Since this is just solving the question paper, we will have a brief answer. Going to the next question. Question number 6. Can an electric heater of 2 kilowatt be connected to a domestic circuit rated 5 ampere and has a potential difference of 220 volt? Support your answer. You are supposed to check whether the condition is possible for a given current and voltage value, and the electric heater of this power, that is nothing but 2 kilowatt hour, is it possible to connect it? So let me write the given quantities. What is power? That is nothing but 2 kilowatt. Voltage 220 volt. This is nothing but 2000 watt. You have to check whether an electric heater of this much power with the given voltage and current flowing through the circuit is 5 ampere, whether an electric heater of this power, that is nothing but 2000 watt, can it operate under these given conditions. Since we know the formula which connects power, voltage and current is P is equal to V into I. Voltage value is 220, current value is 5. 220 into 5, 5 0 0, 5 2 are 10. We will be getting the power as 1100 watt, which is less than 2000 watt. From where did we get this 2000 watt? It was given in the question. So is it possible? No. It will result in overloading. It will result in overloading. Hence, an electric heater with the power of 2000 watt cannot operate in this voltage and current conditions for the given value. There is another method for solving this problem. Let me write the given quantities. Power is equal to 2 kilowatt, nothing but 2000 watt. Voltage is 220 volt. What should be the current for this power and for this voltage? Again the same formula, P is equal to V into I. I is equal to P by V. That is I is equal to 2000 by 220. We will be getting the answer as 9.1 ampere. So a circuit with the voltage of 220 volt, if at all it requires a gadget of 2000 watt to be operated, the current required to flow is 9.1 ampere. But what is the current value given in the question? It is 5 ampere, which is not possible. So this is the justification we will be giving. You can solve it in either of the way. Going to the third main. Seventh question. Draw a circuit diagram that shows the combination of resistors in parallel. We have a detailed explanation about the series and parallel circuit in our channel. You can just have a look for the detailed explanation. This is a circuit diagram that shows the combination of resistors that are connected in parallel. We have taken an example of 3 resistors that are connected in parallel. Name them as R1, R2, R3. Voltmeter should always be connected in parallel across the resistors, and an ammeter should be connected in series. This is a battery. Plug key is closed and the arrow mark ensures the flow of current through the circuit. A circuit diagram without the arrow mark has no value. Keep it in mind. You may lose marks if you forget to show the direction of flow of conventional current. Eighth question. Draw the diagram that indicates the field lines of a magnetic field around a current carrying straight conductor. This is the diagram you will have to draw. Since there is no explanation asked, you will have to keep in mind to show the current carrying conductor, which is a straight conductor, and you will have to show the pattern of magnetic field lines, that is the concentric circles, whose direction will be known or can be identified with the help of Maxwell's thumb rule. Coming to the next question, fourth main, ninth question. An electric lamp whose resistance is 25 ohm and a conductor of 5 ohm resistance are connected to a 5 volt battery in series. Calculate total resistance of the circuit, current flowing in the circuit, potential difference across the lamp and the conductor. First, let me write down the given parameters. 25 ohms, 5 ohms, voltage is 5 volt. So the resistance of the electric lamp, let us take it as R1, and the resistance of a conductor, let us take it as R2. Since it is mentioned in the question that they are connected in series, in order to find the total resistance, we are going to use the formula Rs is equal to R1 plus R2, that is 25 plus 5, and the equivalent resistance or the total resistance in the circuit will be 30 ohms. This is sub question 1. Coming to the sub question 2. You are supposed to find the current flowing in the circuit. From Ohm's law, we know that V is equal to I into R. We are supposed to find I. V value is 5, R value is 30. I is equal to V by R. That is nothing but I is equal to 5 by 30. That is 1 by 6 ampere. You can leave it in fraction or you can take a decimal value also. Going to the third sub question. So we are supposed to find, in the sub question 3, we are supposed to find the potential difference across the electric lamp and the conductor. We are supposed to find the potential difference. Do we know the resistance? Yes, it is given in the question. That is, the resistance of the lamp is 25 ohms, whereas the resistance of the conductor is 5 ohm. Here also we are supposed to find the voltage. Do we know the value of current? Yes, by the answer of the sub question 2, the value of current is 1 by 6 ampere. From Ohm's law, we know that V is equal to I into R. I is 1 by 6, R is 25, nothing but 25 by 6. Its decimal value will be 4.1 volt. Where coming to the voltage that is across the conductor, I into R, 1 by 6 into 5, that is nothing but 5 by 6. The decimal value for 5 by 6 is 0.8 volt. After the decimal point, 1 or 2 digit value is enough. So this is the voltage across the lamp and this is the voltage across the conductor. Coming to the next question. This is our question in 4th main. 50 joules of heat is produced each second in a 2 ohm resistance. Find the potential difference across the resistor. Let me write down the given quantities. 50 joules of heat, nothing but H is equal to 50 joules produced each second, means that is the time is for 1 second. In a 2 ohm resistance means R is 2 ohm. Find the potential difference across the resistors. First we will write the given quantities, then the quantity which has to be found out. From Joule's law of heating, we know that H is equal to I square R T. H value is 50, I square value is yet to be, I square is unknown, R is 2 ohms, time is 1 second. 50 by 2 is I square, that is nothing but I square is root of 25, hence I is 5 amperes. But what are we supposed to find? Voltage. From Ohm's law we know that V is equal to I into R. In place of I we can write 5 and R value is 2. Hence the voltage value is 10 volt. Coming to the next question. In domestic circuits, what are the reasons for overloading? Since it is a 3-mark question and we have sub-questions A and B below 10th question, we will have to judge each sub-question for 1.5 mark. So, overloading can occur when the live wire and the neutral wire come in direct contact with each other. Coming to the sub-question B. What is the need of 15 ampere and 5 ampere circuit? It is very clear, a common sense question. Why do we need 15 ampere? On comparing 15 amperes and 5 amperes, we can make a judgment that here more current is used and here less current is used. So the gadgets which need more power make use of this current and the gadgets which need less power or the less current use 5 ampere as the current. That is, the appliances with high power ratings such as geyser, air coolers, etc. They all need more current. They need 15 amperes, whereas appliances like bulbs, fans, they need less power, they consume less power. As a result, current is also needed in less quantity. They need 5 ampere. Coming to the next question. 11th question. Explain an activity to determine the flow of current is different for different components. So this is the activity which you are supposed to explain. After drawing the circuit diagram as shown in the figure, you will be mentioning that you will be changing the trial. You will be taking 3 trials in which we will be using nichrome wire in the first trial. Then we use incandescent bulb. Then we use a 10 watt bulb. So the current which is going to be used in each trial will be different. That proves that flow of current is different in different components. Let me know in the comment section if you want me to explain the activity in detail. Coming to the next question, 12th question. Explain an activity to draw the field lines around a bar magnet using a compass and a bar magnet and write the properties of magnetic field lines. Before writing the answer, we have to see the marks distribution. Each question carries 4 marks. The properties of magnetic field lines we can stick on to 1 mark, whereas the activity weightage will be for 3 marks. Since it is explaining an activity, the diagram carries 1 mark. You will have to draw the diagram as shown in the figure. And the procedure is, when you place a bar magnet, mark its pole and keep a compass needle where the pointer shows the north pole, and from the next point again place the same bar magnet and point the direction, and go on joining these points for many trials. You observe that on joining these points, the magnetic field lines are emerging from north pole and they merge near south pole outside the magnet. So this is how we draw the magnetic field lines around a bar magnet using a compass. Let me know in the comment section if at all you need this activity explanation in detail. Coming to the properties of magnetic field lines. The magnetic field lines, they emerge from north pole and they merge in the south pole. Magnetic field lines are closed curves. They do not intersect. They do not intersect each other. Here we can also add one more point, that is the magnetic field lines travel from south to north pole inside the magnet. Going to the next question, or question for the 12th question. Explain an activity to show that a current carrying conductor in a magnetic field experiences a mechanical force. Explain the rule that helps to find the direction of force exerted on the conductor. So you will have to explain the activity that is shown in the figure. That is, the conductor AB is going to experience a force on passing current and placing it in a magnetic field which is produced by the horseshoe magnet in its vicinity. The rule that helps to find the direction of force that is going to be exerted on the conductor is Fleming's left hand rule, and the force experienced by the conductor will be maximum when they are perpendicular to each other. That is, the current and the magnetic field, when they are mutually perpendicular to each other, the force experienced by the conductor will be maximum. Coming to the next question, 13th question. Resistivity of materials A, B and C at a particular temperature, that is 20 degrees Celsius, are given in the table. Which material can be used as a conductor and which material can be used as an insulator? Justify your answer. So you have to judge which is best to be used as a conductor and which is best to be used as an insulator, and justification also need to be given. On comparing the quantities of A, B and C, we observe that the material C has got highest resistivity. C has got highest resistivity. That is nothing but 10 to the power 12 ohm meter. And the material which has the least resistance is material B, 1.62 into 10 to the power minus 8 ohm meter. This has got least resistivity. The material with highest resistivity can be used as an insulator, and the material with least resistivity can be used as a conductor. This carries 2 mark. And coming to the sub question 13b, why does the cord of an electric heater not glow while the heating element does? So you will have to write the reason why the heating element is going to glow whereas the cord doesn't glow. The reason is very clearly shown with the help of a mind map. The cord which are going to be used in electric heater, it is made up of copper. We have to write the reason. On passing current through an electric heater, the heating element glows whereas the cord doesn't glow. The reason is simplified with the help of a mind map. The cord of the electric heater is made up of copper. As we all know, the resistance of copper is very less. It is a very good conductor, hence the resistance is less. As a result, on passing current through the copper wire, through copper, nothing but the cord, the heat generated through that also will be less. Hence it doesn't glow. Whereas the heating element in the electric heater, it is made up of an alloy whose resistance is very high. As a result, on passing current, the heat produced also will be more, hence the heating element glows. This is the answer that can be written for 2 mark. Let me know in the comment section if at all you need the solution for biology and chemistry essay 1 paper, which will be uploaded as per your requirement.